leaves us with 8 times 7 over 2. 8 times 7 is equal to 56, and 56 divided by 2 is 28. So now we're ready to do the 1/4 times 8 choose 2. In the place of the 8 choose 2, let's plug in 28, and 1/4 times 28 is equal to 7. So this whole thing is equal to 7. And that's why it's here at 7 o'clock. Now we can go to this one. 2 times 2 squared. I'm guessing they ran out of ideas. 2 squared is equal to 4, and 2 times 4 is equal to 8. So this is equal to 8. Now we can go on to this one. This is the integral from 0 to 3 of x squared dx. Ultimately, what it means is if we graph y equals x squared, where the x squared comes from this right here, it wants to know what is the area between this and the x-axis between x equals 0 and 3. And here's the 0 and 3 here. This is asking for this area. I'm not familiar with the geometric way to find this, so let's switch to these notes. This is the integral power rule. Power rule. Power rule for integrals. It says if you have an integral from a to b of xn dx, the way you evaluate it is you add 1 to the exponent and then you divide by that new exponent. And then you evaluate it from b to a. And I'll show you what this means in a second. So to do this integral, it's going to be x to the 2 plus 1. And then we're going to divide by 2 plus 1. And we're going to evaluate it from 3 to 0. And the exponent, this 2 plus 1 is equal to 3. And this 2 plus 1 is equal to 3. So now we have x cubed over 3 evaluated from 3 to 0. And now I can show you what this means. We're going to do x cubed over 3 minus x cubed over 3. But for the first x cubed over 3, we're going to plug in this 3 for the x. And then for the second x cubed over 3, we're going to plug in the 0. So that's where the 3 and 0 come in right here. We plug in 3 here and 0 here. And now let's simplify this. 3 cubed is equal to 27, and that's still over 3. And then 0 cubed is equal to 0, so there's nothing there. And 27 divided by 3 is equal to 9. So this whole integral is equal to 9. And that's why it's located right here. And going back to this graph from earlier, this region under the parabola has an area of 9 square units. How exciting. I was so excited, I just said that. Now let's go on to this one. This is a summation. It's similar to this one here, except instead of multiplying, we're going to be adding each of the terms. So once again, we have an n equals 1, then n equals 2, n equals 3, and we're going to stop at n equals 4. And the thing that we're going to be adding is n to each of these. So we end up with n plus n plus n plus n for these different values of n. So for the first one, it's n equals 1, and then we're going to add n equals 2, and n equals 3, and n equals 4. And 1 plus 2 plus 3 plus 4 is equal to 10. So this whole thing is equal to 10. And that's why it's in the 10 o'clock spot. Now what's going on with this one? This is